Alright guys, last lesson for Unit 1. We're going to learn a shortcut for finding derivatives of square roots. Now, some of you guys might be thinking, well, we already know how to find derivatives of square roots. We do, but it turns out that we take derivatives of square roots so often, it would be nice to have a shortcut. So we'll show you with you guys a shortcut. And then we're also going to talk about how to find the derivative of an absolute value function. Okay? So all that being said, let's go ahead and jump in. Here's the shortcut for this particular square root thing, right? So we already know how to do this, right? We know that if y equals the square root of x, we know that means that x is being raised to the half power. And so when I take the derivative, I put the half in the front, and I subtract 1 from my power. And then I also know that that x to the negative half puts that x in the denominator and square roots it. And so we jump from here to here, right? And so basically what I'm saying is, well, let's just ignore all this. It's always going to work the same. We can always just jump straight from the top to the bottom since we know what it's going to look like. Okay? So we have a shortcut so that we don't need to actually go through that process. Now we still need to know the process though, because what if I give you something else like this, right? Well, now you need to know how to do it because there's so many different types of roots. But the thing is that the square root is the most popular root, and since it's the most popular root, it also turns out to be the one that's most popular to get square roots, derivatives for, and so it's nice to have a shortcut for it. So let's go ahead and do some examples where that would come in handy. Alright, so here's a couple we're going to do. Number one, well, all of them actually really quick before I get started. They're all chain rules, okay? So we're going to have to apply the chain rule, but since it's a square root, we're also going to apply that shortcut. So first of all, for number one, we have a constant multiple here of 3. So the 3 is going to just stay. When you take a derivative and there's a constant multiple, in other words, a number that's multiplying everything, that number just stays there. It's not going to go away. The next thing we're going to do is we're going to take the derivative of this guy. Now, we could change it to a half power and do everything we used to, but we have a shortcut now. The shortcut is it's going to be 1 over 2 times that square root. So we don't have to go through all that trouble. But there's an inside function here as well, so we need to take the derivative of the inside. So the 3 stays there because of the constant multiple rule. The derivative of the actual square root is this, but since it was a chain rule, we do have to find the derivative of the inside. And so, in the end, this is going to end up the 3 and the 8 both multiply to the top to make 24 over 2 square root of 8x. And of course, the 2 can go into 24 12 times. So final answer would be 12 over square root of 8x. Okay? Now, technically, yes, you could rationalize this and get the square root out. I'm not too worried about that at this time. Just want to make sure that you guys know how to apply the shortcut. Let's do another one real quick here. Go ahead and take a look at part B. All right. So for part B, it's another chain rule, right? We have a inside function, which is the 10x squared plus 1, and then we have the outside function, which is the square root. So starting with the outside function, the derivative of the square root, we have a shortcut for that. It's 1 over 2 and the square root. But we're going to multiply that by the derivative of the inside. The derivative of the inside is 20x. So if we simplify this, we multiply the 20 to the top. 2 goes into 20 10 times. So there we go. All right. So just apply the shortcut and multiply it by the derivative of the inside. Let's do another one. Now the next one is an eggshell, egg white yolk problem. It's a double chain rule. So our yolk is 5x. Oops. and the egg shell is the square root. The egg whites is the ln. So we're going to start by doing the derivative of the outside. The outside function is the square root. So the derivative of the outside will be 1 over 2 and then the square root. Multiply that by the derivative of the egg whites, the ln. The derivative of ln is 1 over whatever's inside the ln function times the derivative of the yolk, which is 5. The 5's cancel, right? And so now my final answer is going to be f prime is equal to 1 over 2 x square root ln 5x. We have the x, we have the 2, and then the square root of ln 5x. Okay, so as you can see, then it kind of makes it nice just to be able to jump straight to that derivative of a square root so that we don't have to go through this process of changing this into a half power and then doing the power rule and then having to go back and rewrite it again so that there's no negative exponents. So it makes things a little bit quicker and it's kind of worth our time. So let me go ahead and give you guys a couple of these to practice. Okay, I made them a little bit harder as they go. So first one a little easy, middle one a little bit harder, last one making you think a little bit, especially about our last lesson. So go ahead and pause the video, see what you guys get for these three, and then you can check your solutions when you unpause it. Okay, so there's your solutions there. I'll let you, if you need to stop the video and pause, to ponder it, you can. I'll explain the last one though. As for the last one, the derivative of the outside, which is the square root, is this, the actual square root function there. And then the derivative of the inside function, the f inverse, is what we learned yesterday. So you just multiply the formula we learned yesterday. So there's that. And you can really just kind of skip the step also, by the way, once you kind of get it. You can skip the step of doing, okay, the derivative of the outside times the derivative of the inside. Oh, and I just realized I made a mistake here on number 1. Anyway, you can skip the step where you do the derivative of the inside times the derivative of the outside. You can just always know that the derivative of the inside is what goes on top. So it can kind of save you trouble. But the mistake I made on number 1 was there wasn't supposed to be an x there. So my bad. Sorry about that. All right, let's move on to our next little rule there. Okay, so here's the derivative of an absolute value. We can't really discuss why this one works as well as we did with the other one. It's just going to be a rule that we're going to use. But if you have a absolute value function, the derivative will be the following. You're going to take the absolute value function and put it on the bottom, and then you're going to take whatever was on the inside and put it on the top. Okay. Now I just have x's there, but you'll see how it doesn't have to be just an x. It could really be anything. But the point is that the whole thing goes on the bottom, and just the inside without the absolute value bars goes on the top. And that's how you find the derivative of an absolute value. And of course, once again, it's going to be a chain rule thing. So let's go ahead and bring this one to life a little bit. So I'll go ahead and start off with something pretty straightforward here. So for the first one, y equals the absolute value of 2x. So here's the basic rule, you guys. You put the entire absolute value thing on the bottom. You put whatever's on the inside on the top. Okay? But now all of these are going to be a chain rule. So what this is this is the derivative of the outside. Okay? But now we need to multiply that by the derivative of the inside. Okay, so the derivative of the inside is 2. And so what this ultimately comes out to be when you multiply the 2 times this fraction is you end up with 4x over the absolute value of 2x. Okay, so there's your absolute value rule. Let's go ahead and take a look at part 2, number 2 I mean. All right, so to find the derivative, we need the derivative of the outside And we need to multiply that by the derivative of the inside, right? So the derivative of the outside, which is the absolute value function, looks like this. You put the absolute value on the bottom, and you put whatever's on inside the absolute value on the top without the absolute value bars. And then you multiply this by the derivative of the inside function itself, which would be 2x plus 1. I'm not going to simplify this one. There's no need to. We'll just leave it like that. If you wanted to, you could FOIL those two things together there on the top, but I'm not going to do that. There's no point in it for now. All right, let's go ahead and take a look at number 3. Now, number 3 is another egg problem. It's got yolk, whites, and shell. So let's go ahead and find the shell. The shell is the square root. Oops. The shell is the square root. So I'll highlight that with a nice eggshell color there. The yolk is the one that's most inside. That would be the x cubed. The egg whites, I can't highlight it in white, but I'll highlight it in green. The egg whites is this absolute value function plus 1. Okay, so we get to apply both rules here. So the derivative of the shell. Let's do the shell first. After that, we'll do the whites. And then after that, we'll do the yolk, right? So here we go. The derivative of the shell. Well, the shell is a square root function. And so that's going to be 1 over 2 and then the square root. Done. Now, the egg whites is this absolute value function plus 1. Now, the plus 1 doesn't matter. We're going to take the derivative of this, and you would usually take the derivative of that also, but it's just a 1, so when you take the derivative, that just goes away. So we don't care about the 1. But the derivative of that absolute value of x cubed, well, how do you find the derivative of an absolute value function? You put the absolute value part on the bottom, and you rewrite it on the top without the absolute value. And then we're going to do the yolk. The yolk is the yellow part there, so the derivative of x cubed is 3x squared. Okay, I'm just going to leave it like that. Well, I guess we could put it together. If you put all the tops together, you would get 3x to the 5th. If you put all the bottoms together, you would get 2 absolute value of x cubed square root of the absolute value of x cubed plus 1. Okay, so that is the derivative of an absolute value. So the basic rule is you put the absolute value on the bottom, you put what's inside on the top. Don't forget to multiply it by the derivative of the inside. All right, so it's your turn. Okay, there are 3 problems for you guys. We start easy, we work our way up a little bit. Go ahead and do as much of it as you can. Pause the video, and when you unpause it, I will show you the solutions. Okay, guys, so there you go. I didn't simplify any of them. I just kind of left it as derivative of the inside times derivative of the outside. So this one was pretty straightforward. This one was an eggshell white and yolk problem. There were 3. The outermost was the absolute value. There's its derivative. The innermost was the 3x. There's its derivative. And the shell was the sine of 3x, and there's its derivative. As for the last one here, it's also an egg, white, shell, and yolk problem. Here's the derivative of the shell, the square root. Here's the derivative of the absolute value, which is the egg white problem, and then the yolk was the x squared. So when you take the derivative of that, you get 2x minus 5. So that is how we find derivatives of absolute value functions. And that is the end of our lesson. Nice and short and sweet.